So in this video, we're going to talk about rate laws. There's two kinds of rate laws, the differential rate law and the integrated rate law. We'll talk about the differential rate law here. The differential rate law is sometimes just called the rate law. And so the rate law is how the rate depends on the concentration. And so what we want to do is we want to be able to describe the rate of a reaction based on the initial concentrations. Before we get there, let's talk about how to write the rate law. So let's start with a very simple generic equation. Let's say we have reactant A, and it reacts to produce reactant B, something like that. The rate law is going to be dependent only on the concentration of the reactants. If you remember the last video where we introduced kinetics, we noticed that a lot of the action, a lot of the kinetics is happening at the beginning of the reaction. Well, at the beginning of the reaction, we have mostly reactants, very little product. So we want to write a rate law showing how it depends on the concentration of the reactants. So here's how we write that. The rate is equal to a rate constant, which is K, times the concentration of A, the reactant. And A, the reactant, is going to be raised to some power. I'll go ahead and call it N. Notice how A is in brackets, so that means that this is the concentration of A. N, that exponent, is the order of the reaction with respect to that reactant. So in this example, N is associated with A, so N is the order with respect to A. K is what we call the rate constant. Okay. So the rate constant is some number. We need to go find that number. N is the order, it's a power. A raised to the N power. That number we need to go find as well. Now I want you to just, before we move on, look at what the rate law tells us. It tells us that if we know the initial concentration of A, if we know what we start with, we can find the rate by taking A and raising it to some power, which we need to go find. And whatever that number is, we multiply by a constant, and that will give us what the rate of reaction is. Let me give you another example. What happens when we have two reactants? A plus B reacts to give us Z. Again, just some generic reaction. Well, we can write the rate law like this. Rate is equal to some rate constant, which we will go find. And because the rate law is dependent only on the reactants, we're going to write the reactants down. A raised to some power times B raised to some power. Notice I've given each species its own power Now, sometimes these powers might be the same, sometimes they're different. And so we need to go find those numbers based on some data. So we'll do that in another example. So again, what does the rate tell us? Well, the rate law tells us that the rate is equal to a rate constant times the concentration of A raised to some power times the concentration of B raised to some other power. N is the order with respect to A. M is the order with respect to B. Now, of course, there's two orders here. Again, sometimes they're the same, sometimes they're different. But now that we have multiple orders, we have the total order of the reaction. N plus M is the total order of the reaction. Or overall order. Okay, one last example here. Very rarely, but sometimes you might have 3 reactants. So in this example, you have A plus B plus C is equal to X. Again, just some generic reaction. So as you would expect, the rate law is the rate is equal to K, concentration of A with raised to the N power times the concentration of B raised to the M power. And again, we've got that third reactant, so we have to include it in our rate law. And I'll give it just the unknown P, for example. So the rate law looks like this. Rate is equal to rate constant times the concentration of A raised to the N times the concentration of B raised to the M times the concentration of C raised to the P. N is the order with respect to A. M is the order with respect to B. And P is the order with respect to C. N plus M plus P is the overall order.